Hello, everyone. Thanks for coming at this H2 Tech Innovation speech, and thanks to the organizer for giving us the opportunity to present this piece of innovation that we have been working on in Tenaris in the past months. So first of all, who we are. My name is Maurizio Bellingardi. I am a technical engineer in Tenaris and working for the hydrogen pressure storage systems. And Tenaris is a global leader in production and supply of pipes and related service for the energy industry. It's a company that is spread all around the world in 25 countries, more or less 30,000 employees and $15 billion turnover last year. What is Tenaris offering for the hydrogen? Depending on the business unit, you will see we are offering pipes, pressure pipes for the production of hydrogen, tube trailers for road transportation of high-pressure hydrogen on the short range, tubular segment for pipelines for the transportation of high volumes in long distances, and concerning the storage, we are offering for, depending on the pressure, if you need high pressure in, let's say, on-site storage, we offer the high-pressure storage solution. And if you need large volumes, we offer tubes for injecting and discharging hydrogen from the underground storages. The presentation of today is related to the storage system at high pressure. We launched the brand THera in 2021, specifically for all the hydrogen product of Tenaris. And in this case, we are talking about the vessels that are used for storing high-pressure hydrogen, typically for refueling stations. And this pressure vessel have a typical tubular elongated shape that you can see in the picture here. And this is what is looking like a typical storage system of 1 ton of compressed hydrogen at 500 or 1,000 bar of working pressure. So basically, in a footprint of a 40-feet container, you can store this quantity of hydrogen using our THera high-pressure storage vessels. And let's come to the core of this presentation. If we look at what is the pressure vessel we are using, you see that it has a robust, safe, and very efficient shape. It is a tubular, so the stresses are very uniform along this shape, and on the ends, you have both ends that are hemispherically turned, so forged, to reduce the stresses also at the ends. Everything here is of seamless construction, and it's made of steel that has been designed and dedicated for the hydrogen specifically and tested to prove the compatibility between the steel and the hydrogen. If you look at the openings, of course, the process is not closing completely. The end is leaving an opening, and the opening is needed during the manufacturing for cleaning the internal surface to perform the visual inspection, but also in the future during the service for the maintenance if you want to look into your vessel. But the hole is approximately 3 inches, so 70 millimeters more or less, is too large for using it as a service for the in and out for the hydrogen. So we use a plug, so a device that is rather simple. It's a mechanical piece provided with a cylindrical thread that it's threaded on, screwed on the neck to provide the closure. And then you have a smaller hole. You can see an example, a real-life example. This is not of steel. This is made of plastic to make it transportable in the airport, even if it was almost not passing the checks. But you see here there is a small hole, it's 13, 16 of an inch to connect your service pipes, okay? So how you prevent hydrogen from escaping your high-pressure vessel to the atmosphere. Because if it's just for the mechanical thread, this is good for keeping the pressure in. But the hydrogen, the gas in general, can find the path here and escape. So you have to put some kind of barrier, and normally this is done using an elastomeric ring. So something made of some kind of technological plastic that it's soft, can deform when it's put in place, and prevent the hydrogen from going from inside to the outside. This solution has very good advantages. It's pretty inexpensive compared to the cost of the plug or a vessel itself. It's expandable, because if you find something that's not good, you just substitute with another one. It's widely available, practically of every size you will need, and it's field proven for holding the high pressure gases. But it has some drawbacks. First of all, temperature range. Those kind of materials are not always looking good when the temperatures goes very, very low, because they tend to become brittle to pass the glass transition. Also, the compatibility with hydrogen in the long term is not always proven by the manufacturer of this ring. And one thing that is particularly critical is the positioning of the O-ring into the, whatever is the position in your plug, is how you position it is very critical, because when it comes to the operation at high pressure, just a small change in position can start a leak. And so you have to be very careful during the assembly of this. And also, this is not very good for rapid decompression, because it's a soft material, and when the flow of gas is very high, it tends to slide and to go again out of position and deform itself. So we came through with an innovation that is the THera seal. And the THera seal is a patent-pending connection that is capable of closing this vessel without the usage of any elastomeric ring, any O-ring at all. How does it work? It's rather simple. The plug is incorporated with a sealing system, and the neck is incorporated with the sealing area, that when you plug in and you make up the plug into the vessel, the sealing area activates automatically. You don't have to position anything, you don't have to take care about the placing of the O-ring. This is another picture of it. As you can see, there is just one plug and the end of the opening of the cylinder. And this means that the sealing is performed directly with the contact between the surface, the metal surface of the plug, and the metal surface of the connection. How we develop this solution? We took advantage from the experience Tenaris has in gas-tight connection for high-pressure gas wells. But we had to think about specifically this solution for the geometry of the vessel, for the specific usage of the vessel, the pressures, and the hydrogen, of course. And we followed basically this flow chart here. We started thinking about ideas about what type of metal-to-metal seal we want to put. If you want to put internal or external, single or dual, what kind of thread profile. And we start producing virtual prototypes, so models, that then had to be finite element analyzed to produce results in terms of stress distribution and sealability. The best in class among all the virtual prototypes we produced have been chosen to be tested in the laboratory. So we produced physically the samples, and we started rising the pressure and then leak testing, or cycling the pressure and then leak testing. If everything was okay, we choose the perfect candidate and we translate it into an industrial product. How we did it? We started working with our industrial department, starting from the engineering and the R&D to the industrial department, to produce the drawings inspection procedures, connection procedures that translates an engineering drawing into something that is real. And then we went to the testing phase, putting together the plug with the cylinder, hydro testing it to ensure that all the mechanical stuff is fine. And then we started pressurizing, depressurizing, making up, breaking out the connection, and checking that the sealability was still guaranteed. And to check the sealability, we used a sniffer of helium with a 10% helium inside. We did it for both 500 and 1000 bar, and we always detected the same amount of helium that is normally in the atmosphere. So no leak detection after those tests. So, summing up everything, TheraSeal is a connection that can be applied to THera pressure vessels to allow to close the cylinders and to ensure the gas tightness without the use of any elastomeric ring, and providing you with this, let's say, additional features. No use of elastomeric ring, already said. Easy to assembly, because you just have to plug in, torque in, following the procedure, and this is, let's say, not giving you any problem in terms of moving parts inside the plug. No need to change after periodic inspection, because this part is not consuming itself. It is hydrogen compatible because it's done with the same material of the vessel. If the vessel is tested for hydrogen compatibility, also the plug that is integral with the vessel is compatible with hydrogen. You can use the vessel to very low temperature without worrying about glass transition of your O-ring. If you want to operate your cylinder at -60 degrees, now you can with TheraSeal. It is suitable for fast loading and unloading, so for fast venting, no problem, the sealing will work. And it is cost competitive. It is not costing you a fortune, because this technology is comparable with the other one. So that concludes my presentation. Thank you very much for being here. If you have questions, if you want to talk with us about this new solution or whatever is Tenaris offering for the hydrogen technology, visit us at booth E70 here, and thank you again. I think I have 2 minutes, 11 seconds for potential questions, if you have any. Otherwise, I will launch this, and who will make a question. It's only 1.5 kilos. Be prepared. No questions? Okay. Thank you very much again.